the great scientist Rutherfords Goldfoil Experiment. In the figure schematic Goldfoil experiment, in 1909, Rutherford discovered proton in his famous Rutherford Goldfoil experiment, bombarded beam of alpha particles on the ultra-thin gold foil and then detected the scattered alpha particles in zinc sulfide screen. This is the zinc sulfide screen. Most of the particles are undeflected here, scattered particles. This is the source of alpha particles from radioactive element. The alpha particles are bombarding through this thin gold foil, which is the famous Rutherford's Goldfoil experiment, my dear friends. Most of the particles pass through the foil without any reflection. Some of the alpha particles deflect at small angle. Very few even bounce back, 1 in 20,000. This is the famous Goldfoil experiment of Rutherford's. In the atomic physics, the important things detecting screen is observed here in the Goldfoil experiment. This is important. In 1911, Rutherford and co-workers Sam Dager and Ernest Madsen initiated a series of groundbreaking experiments. The experimental setup for Rutherford's Goldfoil experiment, radioactive element that emitted alpha particles was directed toward a thin sheet of gold foil. This yellow sheet is called a thin sheet of gold foil, my dear friends. Observe the figure carefully and you can see the surrounded by a screen which would allow a detection of the deflected particles. Most of the atom's mass and its entire positive charge are conformed in a small core called nucleus. The positively charged particle is called proton. Most of the volume of an atom is empty space. The number of negatively charged electrons dispersed outside the nucleus, same as number of positively charged in the nucleus. It explains the overall electrical neutrality of an atom. The conclusion of the Rutherford's Goldfoil experiment, according to the plum pudding model top, all of the alpha particles should have passed through the gold foil with little or no deflection. Rutherford found that a small percentage of alpha particles were deflected at the large angles, which could be explained by the atom with a very small, dense, positively charged nucleus at its center. Based on his observations, Rutherford proposed the following structural features of an atom. Most of the atom's mass and its entire positive charge are confined in a small core called nucleus. The positively charged particle is called proton. Most of the volume of an atom is empty space. The number of negatively charged electrons dispersed outside the nucleus is the same as number of positively charged in the nucleus. It explains the overall electrical neutrality of an atom. So this is the concept of the Rutherford's Goldfoil experiment. And this is the two great persons. Ernest Rutherford is the person. Was awarded Nobel Prize in Chemistry in 1908 for his work in radioactivity. Well, this is another great scientist, James Chadwick, on the right, a student of Rutherford on Nobel. He won the Nobel Prize in Physics in 1935 for his discovery of neutrons. So, my dear friends, we have studied about the subatomic particles of an atom. That is, the important is electron, protons and neutrons. In the forthcoming class, let us study about the discovery of neutron by James Chadwick. Thank you for listening. If you like our BBSM Academy classes conducted by Veerabhadraya Demaya, please call cell number 9663828428. If you like our videos, like, share and subscribe. And don't forget to press bell icon. Please subscribe, sir. Thank you. Thank you, my dear students.